failing physics, passing French. The reason why we're adding these is because your probability is increasing because you're adding up each one, because you could pass math, or you could pass physics, or you could pass French. So when we do that, multiply, and we add to get 0.092. Number 7, a fair coin is flipped 4 times. Find the probability will land up heads each time. So you have 1/2 times 1/2 times 1/2 times 1/2, which would be 1/16. The probability will land the same way each time. So what we're saying is we could accept 4 heads or 4 tails. So each of those probabilities would be the same. So we're adding them then to get an answer of 2/16. Now, we want this in lowest terms, so it would be 1/8. Question 8. A first grade class of 9 girls and 7 boys walked into a class in alphabetical order by last name. What is the probability that 3 girls are the first to enter the room? Show your calculation. Well, the probability of being a girl in this class would be 9 out of 16, because there's 9 out of a total of 16 students. Probability of being a boy would be 7 out of 16, because there are a total of 7 boys out of 16. So if we want the probability of girl, 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 we're going to multiply 9/16 times 8/15. The reason why these decrease is because you're not going to have the same girl walking in the room again. So we subtract 1 from each the top and the bottom. Same thing here. We subtract 1, so now it's 7/14. We multiply those to get 0.15. Number 9. A bag of marbles contains 12 red marbles, 8 blue marbles, and 5 green marbles. If 3 marbles are pulled out, find each of the following probabilities. In each, we specify either replacement, the marbles go back into the bag after each pull, or not replacement. Round all answers to the nearest thousandth. So it says find the probability of pulling 3 green marbles out with replacement. So I'm pulling a marble out, looking at it, putting it back in. So the probability of green marble will be 5 out of 25. 5 green, 25 total. And because we're putting it back in, we can access that marble again. So we multiply the 3 of these to get 0.008. B, find the probability of pulling out 3 red marbles without replacement. So without replacement means we're going to be decreasing one of the red marbles and also one of the total marbles. So the first probability is 12 out of a possible 25 times 11, because we have 1 less red marble, 1 less total marble. And then the third time you have 2 less red and 2 less total to get 0.096. C, now it says find the probability of pulling out 3 marbles of the same color without replacement. So we're not putting the marble back in after we take it out. This is more complex than previous problems. So we have probability of red, red, red. Well, we just found that out, all right, without replacement, which was 0.096. Now, I went back, because you're not supposed to round until the very end of the problem. So I went and put this to the 4th decimal place. You also could have probability of green, green, green. 5 greens out of total 25, then 4, then 3, and decreasing here as well. Blue, blue, blue without replacement. Start off with 8, second one would be 7, 6, and so on. So we get these, add them up, round to the nearest thousandth, and I get 0.124. D, find the probability of pulling out 2 marbles, 2 blue marbles, and 1 green marble in any order with replacement. So you're, once again, taking the marble out, putting it back in. So you could have blue, blue, green, you could have blue, green, blue, or you could have green, blue, blue. Because the only parameters that we have here, it has to be 2 blue, 1 green. So here I have 8 times 25, 8 25ths times 8 25ths times 5 25ths. And obviously following with the probabilities of each, then here. The reason, once again, why we're adding is we could accept this option, or this option, or this option. So we have to add those probabilities up. We round to nearest thousandth, and we get 0.061. If a safety switch has a 1 in 10 chance of failing, how many switches would a company want to install in order to have only a 1 in 1 million chance of them all failing at the same time? Show your reasoning. So now we're actually going to use exponentials here. So 1 out of 10 chance of failing. We got to figure out how many times. well, it'll be equal to 1 out of 1 million. So the first thing that I did is I wrote these with a common base. Obviously, we're negating because we took the reciprocal. So this would be 10 to the negative 1/6. This would be 10 to the negative 1, so negative 1 times x. The bases are the same, so we simplify those out. You have negative x equal to negative 6. Divide by negative 1, you get x is equal to 6. So it would take 6 times to answer this question. Last question from this packet. If the probability of winning a carnival game is 2/5 and Max played it 5 times, write an expression that would calculate the probability he won the first 3 games and lost the last 2. Use exponents to express your final answer, but do not evaluate. So now, winning is 2/5, losing is 3/5. So we have win, 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 2/5, 2/5, 2/5, loss, loss, 3/5. Now, if you did that and it said expressed in exponents, you would lose a point. What you need to have for this would be 2/5 to the third, because there are 3 of them, times 3/5 squared, because there are 2 of them. So actually, this would be the correct answer based on the instructions. Thank you.